Assalamualaikum. So, fundamental theorem of calculus part 1, which we have already learned in last videos. In this theorem states that if f is continuous and closed interval ab, then fx, this uppercase f also depends upon the variable x, and this is defined by integral from a to x. Upper limit of this integral is x of ft dt is continuous on closed interval ab and differentiable on open interval ab, and its derivative is fx, small fx, lowercase fx. So that is, in short, derivative of this f, that is f prime x, is equal to d by dx of this integral from a to x ft dt, and this is equal to fx. Now part 2 of this theorem, if f is continuous over closed interval and this uppercase f is any antiderivative of this small fx on closed interval ab, then integral from a to b fx dx is equal to f of b minus f of a. And you are already familiar with this part of the fundamental theorem of calculus, and you have already used it to solve the definite integrals. So let's do a few examples to have deep understanding of both the parts of this theorem. So for this I am starting from question number 29. And in this question we have to evaluate this square root of pi by 0 to square root of pi by 2 x cos x square dx. Now the question here is, guess an antiderivative for the integrand function, validate your guess by differentiation, and then evaluate the given definite integral. So first of all, integrand in this case is x cos x square. Now first step is to guess an antiderivative of this function. So antiderivative sine x square divided by 2. Okay, this is my guess, or we can have plus c for constant of integration. And validate your guess by differentiation. Now validation. So validation step, we just need to differentiate this to see if we get this function integrand. So d by dx of sin x square over 2 plus c, where c is a constant, is equal to cos x square over 2 into derivative of x square, which is 2x, and this is equal to x cos x square. So this is the validation step. Now next step, last step, what we need to do, evaluate the differential, definite integral. Now to evaluate 0, square root of pi by 2 is x cos x square dx, and this is equal to, we will not consider c in this case because by plugging in the limits c doesn't make sense, c minus c is 0, so it will vanish anyway. So I'm not going to write antiderivative with c, I'll write without c. So this is equal to sine x square over 2 from 0 to pi by 2. And this is an application of part 2 of fundamental theorem, right? And this is equal to sine under root pi by 2 square is pi by 2. So sine pi by 2 minus sine 0 and whole divided by 2. And this is equal to sine pi by 2 is 1 and sine 0 is 0. So 1 by 2 is the answer. Now this is how you can do all the questions from 29 to 32. Now let me do a question for the application of fundamental theorem part 1. And for this I am doing question number 39. I'll start with question number 39 and I'll do a few more questions. So question number 39, and find dy by dx, where in question number 39 y is equal to 0 to square root, no, there is no square root, there is x, 0 to x, square root of 1 plus t square dt. So according to fundamental theorem part 1, derivative of this integral, that is dy by dx, is equal to dy dx of 0 to x square root of 1 plus t square dt. And this is equal to, we'll just apply the fundamental theorem and the answer must be f of x, that is this is small f t, so f of x, that is square root of 1 plus x square. This is the answer. Now next question. Again question is find dy by dx. Basic question is same, and I will be doing question number 42. We have to find dy by dx, so y here is x multiplied by 2 to x square sine t cube dt. Okay, now we have two functions of x and this integral. So in order to find derivative of this function, we will use product rule. So let me apply product rule first, then we will apply fundamental theorem part 1. So dy by dx, derivative of y with respect to x is equal to d by dx of x 0 to x square sine t cube dt. And this is equal to derivative of x into integral as it is, that is 1 into d by dx of 0 to x square sine t cube dt plus in this case x as it is, right? X as it is. So derivative of x, this is 1, and integral as it is 0 to x square sine t cube dt. So let's simplify it. So x into derivative of this integral is sine x square cube into derivative of x square, which is 2x, plus integral 0 to x square sine t cube dt. And finally 2x square sine x 6 plus 0 to x square integral of sine t cube dt. So this is the answer of question number 42, and I hope you would have understood now how to apply both the parts of fundamental theorem of calculus, and that's all.